class, this is the last lesson for Chapter 6. It's 6.6, Use Proportionality Theorems. So our goal here, we're going to use proportions with a triangle or with parallel lines. So here, the triangle proportionality theorem says if a line parallel to one side of a triangle, okay, so notice right here, here's the side of a triangle and we have that line is marked parallel to that other side. So if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So if TU is parallel to segment QS, then we know that RT over TQ, so RT over TQ is equal to RU over US. So notice these are on the same side of the triangle. Those are on the same side of the triangle. So when we write our proportionalities, or when we write our proportions, our problems here, we want our numbers to be from the same side of the triangle. So the converse of the triangle proportionality theorem is that if a line divides two sides of a triangle proportionally, then it is parallel to the other side. So what this is saying is we're starting knowing that this, RT over TQ, does equal segment RU over US, the distance between those. And if we know that that's true, then we can say that TU, segment TU, is parallel to segment QS. So remember, the sides are not being touched by the line. Those are the ones that are parallel. So let's find the length of the segment. Okay? So we want to find QU. There's our unknown. Here's our two parallel lines. So we say 10 over x, because they're on the same side, equals 12 over 6, because they're on the same side. Use your cross products property. We have 12x equals 10 times 6. So 12x equals 60. Divide both sides by 12. And x equals 60 divided by 12, which is 5. Over here, find KL. So here's my unknown that I'm trying to find. So I'm going to say x over 18, they're on the same side, equals 44 over 24. So notice these two are across from each other and these two are across from each other. I kept it in the same order. So use your cross product property here. 24 times x equals 18 times 44. If I divide both sides by 24 here, if you do 18 times 44 divided by 24, you'll find that x equals 33. And there's your answer, because we were looking for the distance from K to L. Determine if the lines are parallel. So now we're trying to decide, is BD, segment BD, parallel to segment AE? And that would be true if our sides were proportional to each other. So if I say 3 over 6, does that equal 4 over 8? Well, that's 1/2. And 4 over 8, yeah, that's 1/2. So they are proportional. So yes, BD is parallel to, line segment BD is parallel to line segment AE because our sides are proportional. Example 4, determine if line segment QT is parallel to line segment RS. So we want to know if this is parallel to this. So I'm going to write my proportions. 18 over 38. Does that equal 36 over 80? So if you reduce that, I can divide these both by 2, and I get, let's see here, 18 divided by 2 is 9. 38 divided by 2 is 19, so I've got 9 over 19 there. I can divide these both by 4. 36 divided by 4 is 9. 80 divided by 4 is 20. So those are not equal, so these two lines are not parallel because our sides would have to be proportional. Theorem 6.6 says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So we've got our three parallel lines. Here's our triangle, and here's our triangle. They divide these two transversals proportionally. And it splits it up so that UW over WY, so again, they're on the same side, equals VX over XZ. And again, those two are on the same side. Our theorem 6.7 says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So we've got this ray right here bisecting this angle. So those two angles are congruent. That's what bisect means. So segment AD over segment DB. So here's the difference. AD over DB. Those are on different sides of the ray. Okay, so AD over DB equals CA over BC. So you got to remember the two pieces on the different sides of the ray, but that are on the same side of the triangle, you've got to put them together. So let's use this. It says a farmer's land is divided by a newly constructed interstate. The distances are shown in meters. Find the distance, CA, between the north and south border of the farmer's land. So we want to find this whole entire distance. That's my unknown. So in order to find that, I'm going to set up a proportion. Okay? So I'm going to say, well, I don't know this, do I? Let's set up a proportion to find that first, and then we'll find the whole distance. So 2,000 over x equals 2,500 over 3,000. Okay? So solving that, I've got, cross products property, silly me. 2,500 times x equals 2,000 times 3,000. Got 2,500x equals, well, that's quite a lot to multiply, so let's just divide right here by 2,500. I'm going to divide both sides by 2,500, then I'll just put it into your calculator all at once. So x equals, multiply those two and divide by 2,500, and you've got 2,400. So x up here is 2,400. The question, though, says find the distance CA. So my distance CA from the top border to the north border to the south border is 2,000 plus 2,400. So 2,000 plus 2,400 is 4,400, and that's CA, the distance from the top border to the bottom border. This one says find AB. So here's my unknown. Okay, that's my x. I can just put x there. I'm not going to have to do any extra work here. I'm going to set up a proportion. So I'll say 32 over 24 equals x over 27. Use the cross products property. So I have 24x equals 32 times 27. I can divide both sides by 24 to get that x alone. So x equals, if you put 32 times 27 and then divide it by 24, you'll get 36. So we set up a proportion again. X equals 36, and that's AB. Example 5, it says in the diagram, angle DEG is congruent to angle GEF. So that right there is telling us this and this are congruent. So this line segment EG is actually a bisector, cuts it in half. So use the given side lengths to find DG. So we want to find x here. Well, we know this side, if the whole thing's 14, doesn't this have to be 14 minus x? So let's write a proportion. X over 14 minus x, and I have to put those two together. So x over 14 minus x equals 8 over 12. Let's use our cross products property here. I have 8 times 14 minus x equals 12 times x. If I distribute this, I have 112. 8 times 14 is 112, minus 8 times x is 8x. That equals 12x. If I move that 8x to the other side, it's negative 8x on the left, so over here on the right it'd be plus 8x. So I have 112 equals 12x plus 8x is 20x. Divide both sides by 20 here. And x equals 112 divided by 20 is 5.6. So if you go back and check this, this should be 5.6, and then 14 minus 5.6 is right here. Because the question doesn't ask us to find x, it says to find the length of DG. Oh wait, DG is right here. Yeah, that is our x. So DG equals 5.6. Let's look at our last one here. It says example 6. This is find the distance from A to B. So we need to find this. So again, we can set up a proportion. These two are on the same side. This is splitting this up proportionally. We know that because these two angles are congruent. So I can say 1 over 1 equals x over the square root of 2. So my cross product property says 1x equals 1 times the square root of 2. And if you just simplify that, x equals the square root of 2. And that makes sense. If these are both 1, it would make sense that both of these sides are the same as well, that they're the square root of 2. And that is the end of this. Oh, nope, not the end of this lesson. Or is it? Yeah, it is. Okay. I'm a little crazy here. This is the end of lesson 6.6. So remember, star anything that you had questions on. If I went over anything a little too quickly, we can look back at it in class tomorrow. So star anything that you had questions on, and have a great night. Nope, I pressed the wrong thing.